Good day, everyone. Welcome back to another installment of TypeScript Tips. I'm Luke, an instructor and content creator here at Covalence, and today I'm going to continue my exploration into TypeScript Enums. Like I mentioned in the previous video, they are enumerations in TypeScript, a powerful way to aggregate related values, making our code more legible, maintainable, and error-free. #synonyms. In the previous video, I discussed the fundamentals, their syntax, numeric enums, and string enums. So don't worry if you missed it, you can find a link in the description down below. So we're going to dive deeper today. We're going to talk about heterogeneous enums, runtime, compile time enums, and a friend, const enums. And then I'll talk about some general best practices and caveats when using them in your TypeScript codes. Whether you're a seasoned pro or a total newbie, hopefully this video helps demystify what TypeScript enums can be used for. So before we begin talking about the additional complexities of enums, I want to discuss the Covalence community membership. You gain access to a plethora of coding resources to join a supportive community for a monthly payment of $25. You'll have exclusive access to our Discord, meaning being able to harass me for code questions and content, coding events, and some aid with your interviews and portfolio sites, and a complete catalog of courses covering front-end, back-end, an expanded databases topic I'm adding, and a React course I made myself. And front-end and back-end combined are our full stack development course that we offer. So remember, you're never coding alone with the Covalence community. We're here to guide you every step of the way. So if you're ready to take your code to the next level, check the description down below for a link for more information. So as always, you are welcome to hop in wherever you like typing TypeScript code, copy the repo I have linked in my description, or start your own code sandbox with TS added to it, or however you like to start. So, heterogeneous enums. This was one I did not know whether to include in the last video or this one, and it's not exactly the most compelling content to start with, but it's important to know they are a thing. So what are they? Remember, in the previous video, we learned about string and numeric enums in particular. So heterogeneous enums are ones that include both string and numeric elements. And at first glance, this might appear to be a strong feature, but it occasionally results in unpredictable behavior and is typically not advised that you use them. So even though you may choose wisely when writing your TypeScript code, it's worthwhile to grasp how they operate. So, even though you can use them, you kind of shouldn't. It's kind of almost like a last resort type thing. Let me show you what I mean. I can have a mixed enum example where my key of first is a numeric value 1 and my key of second is the string value 2, and etc., etc. This is totally fine. There we go. And is not advisable, as you can probably guess why. This inconsistency can lead to a lot of different problems, right? So we can assign this to two different variables, and we can have a numeric output for one variable and a string output for another variable, and it's totally fine to do so. Like, there is no TypeScript compiling, there's no runtime issues, it's going to work this exact same way. So this enums behavior is definitely going to become less predictable and possibly more perplexing as a result. In general, unless there's a really compelling reason to do something like this, it's called again, heterogeneous enum. It is recommended to either stick to solely string or solely numeric enums whenever possible, right? So if you're wondering, then why even bother showing us this? I mean, I think it's important you know this is a possibility in TypeScript enums, meaning if you see someone doing this and you know it's not advised to do so, you recognize why, and you also know a specific case maybe where this needs to simply be done. So in terms of coming up with a use case, I had to fabricate one and make it a bit of a contrived example. So imagine this was an API response, a third-party API that we are communicating with that has things like a success status code of 200 and a bad request status response that happen to send back the string 400. Something that anyone that's dealt with third-party APIs, especially before the kind of modern proliferation of REST APIs, dealt with, well, APIs coded by developers who weren't really following any kind of guidelines or principles, meaning they wound up with some kind of wonky and inconsistent responses. My students are also guilty of this. If I don't test all their endpoints in Postman, and I'm like, why are these responses different? Why does one send just a status code? Why does one send an object with a status code and a message inside of it, right? So we all know what it's like when dealing with the wild west of third-party APIs. They can respond in various different ways. So a mixed enum, aka a heterogeneous enum, could be a good way to help you consistently solve that problem. So like I said, it's a bit of a fabricated example, and you would be better off working to streamline the response through like a utility function that then spits out everything in a standard way, and your enum will handle it from there. Again, this is kind of a real world scenario. Third-party APIs, we don't know who codes them. They don't all follow the same exact rule set. So it's good to know that if you need a heterogeneous enum for such a weird example, then that's something you could totally use them for. And again, that's why I didn't want to include them at the end of the last video to say, here's some cool stuff about them. Here's also something weird you can do. But also, I didn't know whether that would be very compelling content to start this video. So this is more like, hey, if you want to pass the test by getting asked this random question about heterogeneous enums, you now have it in your back pocket as one of those last resort type situations, including an example of when it might come in handy. So back to fun stuff and enums. So enums have two outputs, one at compile time and one at runtime, which is very interesting to think about because that's actually something that hasn't been consistent in any of my TypeScript tip videos. Everything is typically a compile time only device. Enums break that mold, and I apologize if I said that incorrectly in my last video. I need to rewatch it and make an annotation if I did say that's only a compile time thing. It's not. You can make them a compile time thing, which we'll talk about at the end of the video, but they actually have two outputs. So let's make an enum that I'm going to try and share between several different examples here. So we're going to have an enum with the value of bard. For a bard class, we'll add a wizard today, wizard, and let's add a rouge, a rogue, if you will, right there, a rogue type. I should be consistent with my capital casing keys here. There we go. So this is our enum we're going to be looking at. In any kind of TypeScript application, we might have a function called like assign class, like how I paused on the word ask there, that will have a character class argument passed in that will be of one of these enumerated types, right? So we're going to say it's going to be one of those things, and it doesn't really matter. You are a... it doesn't matter what it actually does. Again, the output, the code implementation is not, the function implementation is not important. It's just knowing that, again, we're passing in the character class enum as a parameter to the assign class function, and the TypeScript compiler will enforce that only valid character class properties and their values are allowed as arguments. So if I call assign class with something like character class.bard, it's like all good to go because that is a valid type. But I can't, for example, say, let's make a new ranger class on the fly for today's game update or game patch. I can't add something that doesn't exist on that character class. So again, at first glance, the usage of enums at compile time is very, very important, right? It uses TypeScript's rigorous type checking system to make sure that our code uses our enums and other types correctly. It enables the useful auto-completion as well. As we saw as I was typing there, we can do character class dot, and having that autocomplete and tooltips for enums in many code editors, not just VS Code's and IntelliSense, is very useful when you're writing TypeScript style code. So offering those possible autocompletes and solutions and things like that is such a fantastic reason to use TypeScript, even if you don't use it to strong type literally everything. Like I've mentioned in some of my videos, it's a spectrum. If you're just using it to help boost your autocompletes and prevent a couple typos and errors, guess what? You're a TypeScript developer. Don't feel ashamed about using it in that regard. So yeah, it adds all this scalability and maintainability to our code just because of TypeScript compiler's comprehension, a lot of C words there, of your enums aid in detecting those potential issues before our code even runs and improves our development experience with those autocomplete syntaxes and things like that. So again, there are obvious benefits for the compile time usage of enums, but did you know that in runtime, enums also exist? And you're like, huh? So let's think about that, right? They're special compared to a lot of other features I've talked about in this TypeScript tips series. They exist both at compile and at runtime, unlike other types. So their use in TypeScript code is made possible by this property in a few intriguing ways. They are compiled, they are actually and really compiled into objects in the resultant JavaScript when they're declared in TypeScript. So when I declare it here, this is going to be an object in JavaScript called character class that should have these properties and these values assigned to it. It contains mappings between the enums, keys, and values, and it indicates that these enums are real in a sense that they can interact with our code at runtime, right? They're not just things that exist to help us compile. They're something we can actually use in runtime. If I had some logic or if-else statements or switch statements, for example, and I had these values here, I could write this code, and again, this is not some TypeScript check. This could be at runtime an if-else statement or a switch statement that does some logic based on this this particular object's property of bard and its string value. So Yeah, like you could use this at runtime, which is so unique about enums, right? So I can actually take a look at this. If I close the app and open the app.js, yeah, check it out. So here is the outputted code of our enum type here. So as we can see in the outputted JavaScript, what it ends up doing is called an IIFE, or immediately invoked function expression, that will be passed in an object as its argument. It will assign that object with the three properties, bard, wizard, rogue, and their string values, bard, wizard, and rogue, all capital case, and it's going to assign that to this hoisted variable of character class, right? So that means that we can use them in logic statements such as switch and if-else statements. It also means that we could go to our application and use them inside of iterables as well. So I could take an object's keys and I can say const key in character class, I'm pretty sure, and key would be, yeah, the key string would be the values of bard, wizard, and rogue that we can then use inside of our code base somehow. So again, not only is this a compiler autocompleter and typo preventer and all that other fun stuff, it also has an output at runtime as an actual object with these properties and values, meaning we can use it in our code, iterables and like conditional specifically, which is very, very important to know. It can be, as long as you're aware that that any changes to an enum can also have real effects on your compiled runtime code, you're going to be good to go. So that's one of its caveats. Know that any changes I make to this enum is going to have potential outputs on my compiled code and not just this code here. So that's important to know about them. So yeah, they're very cool. Compile and runtime benefits, something you don't see all that often in my TypeScript tip videos. Most things are like this, compile time only, right? Not this time around. But there is a way to switch that behavior, meaning if you're like, well, Luke, I don't actually intend to use my enum as an object anywhere in my code. I don't intend to iterate over its keys. I don't intend to use it in any kind of logic, switch statements, or otherwise. Well, we actually have an ability to tell TypeScript, hey, I don't need this outputted into my JavaScript code. So once again, I have the object available here, but if I go back here and switch it to a const enum declaration. So if I add this const enum, variable declaration in front of it, they're a special kind of enum in TypeScript. When I prefix my enum with that declaration const keyword, as we can see right up yonder, what happens is that TypeScript will apply some optimizations that can potentially reduce our JavaScript output size. As we can see here, simply adding the keyword const did not generate an object of those properties. And we can also see that the outputted JavaScript code now simply inlines the values of my enum instead of referencing an object's properties. So it translates things into inline values, no longer referencing properties. So I want to repeat that, keep that in mind. Inline stuff right there. Now, when I use this, I can still use it in my TypeScript code just fine and get all the fun compiler features that we talked about a moment ago without worrying about any kind of output at my runtime. So adding that const keywords is a nice thing to potentially make our JavaScript code smaller and more optimized, faster, whatever you want to call it. You know, it makes it more efficient if you know that you do not need your enum as an object at runtime and it's simply going to be a compile time only tool. You can do that by adding that const keyword right there, and that is important to know about them. And finally, there are caveats and use cases for our friend the enum right here that we have to be mindful of. Being mindful of unexpected values, like I don't know what the default values off the top of my head are for TypeScript here, but if we had a TS config here that was kind of loosey-goosey in its rules, like we're working in a project that doesn't have like strong TS developers, but we want TS features enabled over time, and let's say our TS config allowed for some goofy looking code, we can actually do, unfortunately, some different things here. I can say hero class needs to be a character class type. And as of right now, my compiler will tell me that, hey, dude, you can't assign a value of knight to hero class variable because it's not part of the enum up here of character class. So I didn't change any errors here. I just removed the const declaration because I wanted to be both an outputted and compiled code, or pre-compile and post-compile code. There we go. So yeah, that's saying that's totally fine, but let's say that's not fine rather, but if we had a very loose TS config that, for example, allowed us to get away with some implicit any's and no strict type checking applied to it and stuff like that, a real possibility in a production level code base where they slowly are adding TypeScript features over time. Like if we did have that available, I would never write this, but I'm forcing to write this here to say if we did have loose TS config rules then unfortunately we can bypass TypeScript's type checking system and allow this code and all of a sudden have some really unpredictable and unexpected behavior, both at compile and at runtime if you are not careful. I say caveat to use that here. I would say be mindful of unexpected values. In loose TypeScript rule environments, you can actually do this with no error whatsoever and cause yourself a massive headache down the line if you're not careful. Speaking of being careful, string enums, they are, as you can see, string and numeric enums are the way to go, with heterogeneous only being a last option if you need to. These do not have auto-completion support in the same way that numeric values do, which makes refactoring a bit more challenging. So if I did have, for example, some kind of switch statement that took a character class of some kind, I'll say like let's hero class be character class dot bard, for example, right here, and I passed in my hero class as my parameter to my switch statement, and I had two cases, a default, no class, and a case for bard. But let's say I wrote bard string value there in particular. Again, something you might do in a production level code base or encounter or write yourself if you're not being careful and using code correctly. You are a bard. So that is my simple switch statement right here, and as it stands, it's going to work just fine. However, if I come in here and decide to change this from bard to bardic in my string value, TypeScript will not, for example, go down here and change everything, right? But thankfully, it knows that it can't compare it right there, so in loose TS rules, this won't give you a TS error or autocomplete or auto-update or anything like that, meaning if you have any kind of hard-coded strings you are comparing your enum to, it could have some consequences because now you're going to have to go and change everywhere you're comparing a hard string to match that new value. So that requires a lot of manual find and replacing, whereas numeric enums will automatically update when you change their key, right? So if I changed if all these were numeric keys, they have that reverse mapping feature we learned about in the previous video that allows us to have TypeScript help us auto-update everywhere we might be comparing to a number value of 0. It won't matter if I change the key from bard to bardic because this number value of 0 will always be the same, meaning it's as long as it remains in the same value position of the 0, 1, 2, 3, etc. in my numeric enum, the key name doesn't matter and will auto-update across our code, which is very, very useful to know, right? So remember, this is only going to be an issue if you're doing any kind of manual comparisons to numbers or values and you're not just using the character class enum itself. So like I said, it's best practice to be consistent. Just use string or just use numeric enums. Do not use heterogeneous enums unless you just really have to reach for them as a last resort. And best practice, again, understanding that they have a runtime output, so knowing to add that const declaration keyword in front of your enum to make sure it has only a compile time output. If you don't actually need to do something like this down here, then you don't need to have it outputted into your JavaScript code and can streamline your code base significantly by not having to include it in there. So that will conclude this little mini video series of a TypeScript deep dive on enums. We deconstructed heterogeneous enums, investigated enum behavior at runtime and at compile time, and discovered the benefits of const enums, and I talked about a couple of caveats and best use cases for using enums in TypeScript. So as with everything else, they are another powerful tool in your TypeScript toolbox, allowing you to produce clean, comprehensible, and maintainable #meme code. So did this video help you understand enums? If so, give it a thumbs up and share your own experiences, questions, or ideas about enums in the comments down below. And if you haven't already, click that subscribe button to keep up with my TypeScript tips series, as well as all the other cool videos we put out on our channel. So thanks for listening to this episode, and as always, I'm Luke, and I wish you a successful coding adventure.